Okay, today we're looking at section 3.3, division of polynomials. So we'll review what is called the division algorithm. So suppose that f of x and d of x are polynomials where d of x does not equal 0, and that the degree of d of x is less than or equal to the degree of f of x. Then there exists some unique polynomials q of x and r of x, such that f of x equals d of x times q of x plus r of x, where the degree of r of x is less than the degree of d of x, or r of x is the zero polynomial. Note that f of x is called the dividend, d of x is the divisor, and q of x is the quotient, and r of x is the remainder. So let's look at how to do this. We want 4 times 3x cubed minus 23x plus 3 divided by 2x minus 5. So long division. 2x minus 5 goes into 4x cubed. Now, the thing about this, doing this long division wise, I don't have an x squared term. So I just put in 0x squared minus 23x plus 3. And here's how we look at this. We look at this 2x here. What times 2x gives me 4x cubed? Well, that would simply be 2x squared. So 2x squared times 2x is 4x cubed. 2x squared times negative 5 is minus 10x squared. Now I'm going to subtract this from my top number here. And here I end up with negative 10x squared. Then I bring down this 23x. Okay, now 2x times what gives me negative 10x squared? Well, that's simply negative 5x. So negative 5x times 2x gives me negative 10x squared. Negative 5x times negative 5 gives me, oh, this should be plus. We're subtracting a negative. So I want plus 5x. This gives me minus 25x. Subtracting again, 10x squared minus 10x squared is 0. 23x, or negative 23x minus negative 25x gives us 2x, and then we bring down our plus 3. Well, 2x times 1 equals 2x, so we simply 1. I have 2x minus 5, subtracting again, and I have 8. Positive 8, so plus 8 over 2x minus 5. So my solution is 2x squared plus 5x plus 1 plus 8 over 2x minus 5. Okay, on this next one, there was a typo. This should be 2x to the fourth, not 4x to the fourth. Same principle again. We have x squared plus 3 x squared plus 3 goes into, in this case, I have every degree from 4 down. So I have 2x to the fourth. I have minus 3x to the third plus 5x squared minus 7x plus 1. Follow the same routine. X squared times 2x squared gives me 2x to the fourth. And here I have 3 times 2x squared, which is 6x squared. Subtracting that, this becomes negative x squared, and I need to bring down this, so minus 3x to the fifth, not fifth, third. Minus 3x to the third, so I have minus 3x to the third minus x squared. Okay, x squared times negative 3x gives me minus 3x cubed. Then I have negative 3x times 3 gives me minus 9x. So I need to bring down this minus 7x here as well. Oops, not there. Minus 7x. This is minus 9x. Subtracting, I end up with 2x here. I need to bring down this negative x squared. That's a positive 2x plus 1. So this is simply minus 1 to give me, let's go ahead over here, negative x squared plus 2x plus 1. Negative 1 times x squared is negative x squared. Negative 1 times 3 is negative 3. And of course, nothing there. Subtracting this whole thing, I get 2x plus 4 is my remainder. Then my solution is 2x squared minus 3x minus 1 plus 2x plus 4 over x squared plus 3. Okay, and then we'll do one more. So 3x squared minus 14x plus 15. I have every degree, so I don't have to worry about any placeholders. Divided by x minus 3. So x minus 3 goes into 3x squared minus 14x plus 15. Now x times what gives me 3x squared? That would be 3x. 3x times x is 3x squared. 3x times negative 3 is minus 9x. Subtracting this, negative 14x minus a negative 9x gives me negative 5x. Bring down my 15. X goes into negative 5x. Negative 5 gives me negative 5x plus 15. Again, subtracting, I get 0. So my solution is simply 3x minus 5. Now, there are other ways to do this. There's another way shown in the book called synthetic division. You may have learned this. If you're comfortable with doing it that way, I do not have an issue with you doing it that way. The, this, we just want to teach you this way because we will need a method to do this for a later section. Beyond that, we won't really use this a whole lot. But that is how you do division of polynomials.